Hello everybody, this is your math teacher and my tutor ID is mymathworld5004. I hope you all are fine. Okay students, so today we have a new topic which is the trigonometry. So let me first introduce trigonometry with you. In the trigonometry mainly we have three common ratios which are sine. First is the sine ratio, second one is the cos ratio and third one is the tan ratio. Okay, so let's also draw a triangle and try to understand this concept. For example, this is a right angled triangle. Okay, this is a right angled triangle and we can take this right angle exactly where the lines are perpendicular to each other. This should be the right angle. Okay, so now let's take the angle theta on this side. This is the angle theta. This side is going to be the opposite side and the other one is the base. This is the base and the remaining side is going to be the hypotenuse. Okay students, so let me first tell you about the opposite side, and why this side is opposite, because it is exactly opposite to the angle theta. This side is exactly opposite to angle theta, that's why we call that side as the opposite side. Okay, so now, if we denote this opposite by O and this base by B and this hypotenuse by H, then we can define the sine, cosine and tan ratios as sine would be equals to, in fact this should be sine of the angle theta. Sine theta must be equals to opposite over hypotenuse, so O over H, and cos theta would be equals to base over hypotenuse, and then third one is the tan. Tan of the angle theta would be equals to opposite over base. Okay, so these three are the very basic trigonometric ratios. After this we have the co-ratios, that are the cosecant. We can write them on this side, cosecant theta, and then we have secant theta, and last one is the cotangent theta. Okay, so cosecant theta is just the reciprocal of the sine ratio. So that means if sine theta is opposite over hypotenuse, that means cosecant theta would be hypotenuse over opposite, and secant theta is the co-ratio of the cos. So that means if we take the reciprocal of the cos theta, that would be the answer for the secant theta. So that means this would be hypotenuse over base, and cotangent is the co-ratio for tan, so it would be then base over opposite. So these three are the 6 ratios that are relevant to the trigonometry, and we will use these ratios to do the trigonometric questions. So let's do this question which is given over here. Write trigonometric ratios for angle in any quadrant. The point P is minus 8 and 15. Minus 8 is the x coordinate and 15 is the y coordinate. Lies on the terminal arm of an angle theta in standard position. Determine the exact trigonometric ratio for sine, cos and tan theta. For this question we first need to show this point which is minus 8 and 15 on the axis. So let's draw some axis. We can write on this side. This is going to be the y-axis and x-axis would be on this side. This is the x-axis. Okay, so now we have to show this point over there. X coordinate is minus 8, so let's take this minus 8 over here. This is minus 8, and y coordinate is 15, so we can take positive 15 on this side. Y coordinate is the positive 15. Okay, so that means the concerned point would be this one, where x is minus 8 and y is 15. This is the required point P which is given to us. Okay, so now to make a triangle, since we have to apply the trigonometric ratios by the use of a triangle, our right angle triangle must be required here. So let's try to make it. This is the point which is parallel to the y-axis, which is 15. Okay, and on the other side, and on the x-axis, this is this line which is exactly on the x-axis. We can take this. Okay, so on the x-axis we have this line which is -8. Its length is -8, and the length of the line which is parallel to the y-axis must be 15 because it was given to us. And okay, so now we need a resultant line. We can show that resultant line over here. Okay, so here is the resultant line. We can show it by the h. Next task is to find the value of this h. We can apply the Pythagoras theorem to get the value of the h. So h square would be equals to 15 square plus -8 square. This is the application of the Pythagoras theorem. Okay, so now h square is equal 225, because 225 is the square of the 15 plus 8 square is 64. Okay, so then h square is equal 225 plus 64, which is going to be 289. Okay, so now we don't need the value of the h square. We should have the value of the h without any square. So let's apply the square root on both sides. So after taking the square root, it would be then 17. The value of the h would be 17. So let's write the 17 on the diagram. Okay, so now we have the answer for all the sides. We can bring this 8 little bit on over here, because that's the exact length. That's the exact length. Okay, so now all the values are known. In this triangle we can apply the trigonometric ratios to it. So first start from the sine theta, and theta in this case would be this angle. Why we are taking this? Because it should be linked with the x-axis. For example, if this is the resultant line and this is the x-axis, then that means theta must be between resultant and the x-axis. Okay, so sine theta, according to the basic formula which is written over there, would be equals to opposite over hypotenuse, and in this case opposite is this side, which is 15, base is -8, and hypotenuse is already there, which is 17. So now sine theta is equal opposite over hypotenuse, so that means it would be equals to 15 over 17. Okay, and then next task is to do the cos theta. Cos theta, the formula for the cos theta is base over hypotenuse, and in the triangle base is -8 and hypotenuse is 17. So let's write the 17. Third thing that we have to do is the tan theta. Tan theta is equal opposite over base. Opposite is 15 and base is -8. Or we can also write this term as -15 over 8, because doesn't matter if we write negative as the like factor, or we just write it with the 8, doesn't matter, it's the same thing. So these are the three ratios that were supposed to be obtained by the use of this triangle, and this triangle was obtained by the use of this point, and this point was in the second quadrant. For example, if we try to show the quadrants, this is the first quadrant, this is the second quadrant, third quadrant and fourth quadrant, and that point was in the second quadrant because x value was negative and y value was positive, which is exactly in the second quadrant. And we got that triangle which was also in the second quadrant. So according to this triangle, opposite was 15, hypotenuse was 17 and the base was -8. So by the use of these values we have got the values of the sine theta, cos theta and tan theta. So I hope everything is clear to you and I hope you enjoyed the session. Join us at www.mymathworld.com, and dear students, please subscribe the channel and share it with your friends and family. Stay safe, take care of yourself, your families and the channel. Have a good day. Bye.